Hi guys, today we'll be going over a problem by name single number. It's again an easy problem. So the problem statement is something like this. You'll be given an array in which every other element appears twice except one. So you need to find that one element which appears only once. So let's go a couple of examples. In the first example, input is 2, 2, 1 and we need to find 1 because it appears only once. In the second example, 4, 1, 2, 1, 2 and you need to find 4. So you have two methods to solve this. So one using set and second one is by using bitwise operation. So let's go over both the solutions one by one. So in the solution including set, right? So you pick an element and try to see if it is there in the set. If it is there, you're gonna remove it. If it is not there, you're gonna insert it. So in this way, the set will contain only one element at the end which occurs only once, okay? So let's go with the example. So you have first element. As it is not present in the set, you insert it. Then the second element is 2 again. So it's already present, you remove it. And when you encounter 1, you add it. And that's the end of the array. So as you can see, we are remaining with only one element in the set, which occurs only once, and that's 1. So let's go with the second example as well. So you encounter 4, you add it because it's not present in the set. Then you encounter 1, you add it. Then you encounter 2, you add it again. Then you encounter 1 again, so you go ahead and remove it. Then you encounter 2, so you go ahead and remove 2 as well. So as you can see, at the end of the array, there's only one element in the set, which is occurring only once, and that's 4. Let's go with the second solution. So in this case, we are using Xor operation. So you have two rules here. If you are XORing a same element with itself, then the result is 0. And if you are XORing any element with 0, you get the same element back. So you need to keep in mind these two rules. Let's go with the example. So you take an initial variable m, which is equal to 0. Then we XOR all the elements with the result of the previous statement. So for the first time, you XOR m with the first element of an array. So you XOR 0 with 2. As you can see from this rule, you get the same element. Then you XOR the result of this with the next element, which is 2. So with this rule, you get it as 0 again. 0 XOR with the third element, 1. So you get 1. That's the end of the array and the result is 1. Similarly, you can try for the second example as well and let me know how that works. And this is a very easy problem. So if you have any other questions or queries, or if you want me to solve any specific problem, please do let me know in the comments below and keep learning every day. Thank you.
Hi guys, as I've already explained the solution for this problem, so we can solve this problem in two methods. So one is using sets, which will have an extra memory usage. Second one is using a bit manipulation. Let's go with the problem first. Given a non-empty array of integers, every element appears twice except for one. Find that single one. Okay, for example, 2 to 1, we need to return 1 because that occurs only 1, and same in the example 2. Let's solve this problem first using sets. Then I'll be solving using bit manipulation as well. So what are our base conditions? Let's say if the size of the input vector is equal to 1, then we return the first element. Okay. Let's say if size was 0, then we return -1. Okay. Let's take a set, an ordered set, which will store integers. Let's name it C. Okay. For all the elements in the vector, so we pick every element and see if it is there in the set. If it is not there, we add it. If it is there, we delete it. Okay. For example, for the first time 2, it won't be there, we add it, and for the next time we remove it. And when we hit 1, we add it. So finally, the set will contain only the elements which are occurring only once. Okay. If c dot find dot end c dot erase. So if it is already there, we're gonna erase it. If it is not there, we're gonna add it. Okay. So after this, all the elements which are occurring once will be there in the set. So we return those. So if we didn't find any element, then we need to return -1. So let's run the code. Oops. Okay. It's like it passed for the base condition. Let's submit and see if it passes for all the test cases. Okay, looks like it passed for all the test cases. As you can see, runtime is 28 milliseconds, but the problem here is it uses a large amount of memory. So this can be solved in bit manipulation. So we'll go over that in a minute. If you have any inputs or concerns for this particular solution, please leave them in the comments below and do what. Hi guys, let's solve this in bit manipulation now. So here are the two rules, what I've already explained before. If we have an element A, if we XOR that with 0, we get the same element. And if we have, whenever we XOR same element with itself, we get 0. Okay, so let's take integer 0, and basically we go over the input vector and XOR that with the missing element I and return missing. That's it. So basically, initially, if you have the input 2 to 1, so whenever you take the element 0 and XOR with 2, it will result in 0. Then again, sorry, it will result in 2. Then you XOR 2 and 2, you get it 0. Then you XOR 0 and 1, you get the 1. So that's the element we are looking for. That's it. Thank you. As I said, if you have any inputs or queries or concerns regarding the solution, please leave them in the comments below. Keep learning every day, and thank you for watching. Do like, share, and subscribe. Thank you.